So the first one we're going to look at here is problem B on this week's worksheet. So we're doing some limits here. You see that if you plug in 0, you're going to get 0 on top, and then e to the 0 is just 1, so 1 minus 1 is 0. So you get 0, 0 if you plug just try and plug the x value in there. So we're going to do L'Hopital's. So you're going to want to take the derivative of the top and the derivative of the bottom. So the derivative of sine of 3x is going to be cosine of 3x squared times the derivative of the inside, which is just going to be 6x. Now that's all going to be over, derivative of 1 is going to be 0, minus derivative of e dx squared is just e dx squared, times the derivative of the inside, which is 2x. Okay, so now you look at it and you see that if you plug in 0, because of the 6x and the 2x, you're still going to get 0 over 0, so that would be bad. And if we took another derivative of this, we'd get a sine term here, and the sine of 0 is going to also be 0. This stuff's still going to be e to the x, and it'll still be multiplied by this 2x, so we'll still have 0 over 0 if you take it again. So the trick that you need to look at here is the x's. They're going to go ahead and you can cancel those x's out, since the 0 is not even there. E to the x squared times 2x, and the top is being multiplied as well, so you can go ahead and cancel the x's. Once you do that, now you see that if you plug 0 in, 0 squared is 0 times 3 is 0, so the cosine of 0 is going to be 1, and then times 6 on top, so you got a 6 there, and then you're going to get e to the x squared, and that's going to be just 1, and then multiplied by 2 on the bottom, so you're going to get 6 over 2, and that just reduces down to 3. The next one we're going to do is f, which you see here is if you plug in 0, then you're going to get the natural log of 0, and that's not good, that's undefined, so you can't just plug in the x, so we need to do something else. L'Hopital's is what you want to do, but when you do L'Hopital's, you got to have something over something else. So we need to write this in another way. So what you can say here is the natural log of x over 1, so that's just the natural log, divided by 1 over x is this equivalent to this. You see that? Because if you take this, you can flip the fraction there, so the x will come on top, and you got x ln x over 1. So that's exactly what it is. So this is what we're going to transform it to, and we still want to take the derivative of this. So as x goes to 0, see that if you plug in 0, you're still going to have issues, so we're going to go ahead and take the derivative. So keep your limit, x goes to 0. Derivative of the natural log is just going to be 1 over x. Derivative of, well, yeah, so just the natural log. And then you're going to take the derivative of this guy down here. So this guy here is really x to the negative 1. So you get a negative x to the negative 2. So that can be rewritten as 1 over x over negative 1 over x squared. You see that you can go ahead and flip that up again. Keep your limit. So when we go ahead and flip that, my negative stays. So limit is x goes to 0. So the negative stays. I'm going to get an x squared on top and x on the bottom. X squared on top will cancel with the x on the bottom. So it's negative x. Plug 0 in for x, and your answer is just going to be 0.